go. Okay, today is the day we finally hand in the lab. It's actually not called the Tide Lab anymore, my bad. It's called the Daylight Lab, but that'll happen later. For today, it's about graphing in polar. And let's make sure you can graph in regular first. Do you even know what the name is for the regular kind of graphing you've been doing all along? Regular graphing. No, that's not really it. It is called rectangular. That's what you've been doing all along, because I don't know if you ever noticed, but you're making little rectangular boxes when you graph a point like that. So everybody graph the point 2 comma 4. Just graph the point 2 comma 4. And then make the triangle around it. There is a natural logical triangle that goes around that. So the point 2 comma 4 has a polar way that you could describe to get there. So like if I was starting right here and this was a game where you like shout out and say, okay, where do I go? And you would be like, well, go to the right, go to the right. And then once I got over to about here, you would say, then I go up until you keep going up, and then okay, stop. You know what I mean? You could direct somebody there. All right, so you could say go to the right 2 and go up 4. But in a different world, you could say, I'd like you to go a total of this distance, which by the way would be, well, if this is 2 and this is 4, it's not 6. What's this last one? Square root of something. Square root of 20, I think, is right. Does that seem right to you guys? Okay, square root of 20. 16 and 4, I'm squaring them. 16 and 4. Okay, square root of 20. Could you agree that that would be the same as the square root of 4 and the square root of 5, which makes 2 root 5? Okay, so then this dot right here, I'm going to make it bigger and bolder. This green dot that we've been focused on all along, that guy right there, that could be the point 2 root 5 comma an angle. This angle. Would you agree that we've done a whole lot of things that have like, they look kind of like that, and then we've been talking about the angle that it would make? Would you agree that that is bigger than a 45-degree angle? Do you think it's more than 45? Yes, definitely more than 45. All right. And if it was 45, wouldn't the point have had to have been like 4 comma 4? Think about it. You know what I mean? If the point had been 4 comma 4, that could have been a 45-degree angle. All right. So that angle is more than 45 degrees. Does it seem like maybe less than 60 degrees? Okay. So it's some strange angle, but you definitely have not memorized the 2, 4, 2 root 5 triangle, right? You haven't measured, you do know the 1, 2 square root of 3 triangle, and you know the 1, 1 square root of 2 triangle, but you don't know the 2, 4, 2 root of 5 triangle. So we don't know the angle. Can we just say, no, I don't know the angle? Well, you can, but on the test, you'd have to say the angle here, this angle right here, that angle is the inverse tangent. Ooh, that's why we learned this after the inverse trig unit. It's the inverse tan of, somebody smart should know. What do you think, sir, in the back? I agree. Can you simplify that for me? The inverse tan of 2. Because that's really 4 over 2. TOA, opposite over adjacent, 4 over 2. If you're like, what just happened there? Tangent of this unknown angle would be 4 over 2. And then we wrote it as inverse tan. But I only get one angle then. Well, that's right. That's the right angle. Now, I started off with a pretty tough one. We'll do another easy one, and I think it'll make more sense and be easier. But I wanted to show you an intense, like this is a typical hard polar problem. Yes? Good question. You could have said inverse sine of blah, 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 but here's the beauty of tangent. You never have to figure out the hypotenuse. You could have told you the angle with just the 4 and the 2. You never have to figure out that it's 2 root 5 is the third side. You know what I mean? So tangent is usually used, and we're going to ask you to give your answer with tangent. I get you could have said inverse sine and still gotten it across, but the convention, the normal way to do it, is to use tangent. All right, so let's see if you can do an easy one now that I explained how to do a hard one. But with no help, I'm guessing you can do this easy one. If the point I want to graph is 3 comma 3, and 3 comma 3 is approximately the r, now my question for you is, how could you have said that with a radius of a circle, r, comma, a theta, an angle? I know you didn't probably think of that first one as a radius. You probably just thought of it as the hypotenuse. And you can think of it that way if you want to. How many of you already had drawn in the triangle? Raise your hand if you knew enough to do that. That's smart. We've been doing triangles all along. I told you when we started second semester, you are going to draw so many right triangles this semester. And you should have labeled this with a 3 and this with a 3. How about the last side? What do you think? Square root of 18. Anybody want to go all fancy pants and make it better? Yes? 3 root 2, even better. Okay, then your r, radius, is 3 root 2. What's the angle? Ooh, I know this one. Do you know this one, Ben?
I think so.
What do you think it is?
45 degrees.
I agree. Say it in radians.
Pi over 4.
Pi over 4. You are correct, sir. You've just done your first polar problem by yourself. How many of you did it right? Nice. So why is this angle pi over 4? Because we know that one. If these two sides are the same, it's going to be the same ratios as a 1, 1, root 2 triangle, which is the 45, 45, 90. And so you probably knew that that was a 45 and thus pi over 4. Okay, cool. Let's do another one, except this time not in quadrant 1. How about a point right here at -1, comma, -1? Tell me the polar coordinates for that point. I'm going to put r, comma, theta just to get you used to that. And I'll explain more about that radius in a minute. It's just the hypotenuse. Helena, what do you think the radius or the hypotenuse would be?
I think the radius is square root of 2.
Perfectamundo. And then the angle. And please don't say pi over 4. Osterhus.
5 pi over 4?
You are correct. But what if I told you that I was waiting for 2 different right answers? As in, like, I was ready to say yes to something else also. Jack?
-3 pi over 4?
You got it. Instead of 5 pi over 4, I could have said -3 pi over 4. Because they're coterminal angles. You remember that phrase? Isn't there another way we could say it? Yeah, there is. There's even more. But first I want to get you good at simple ones. Then we'll go more complex. All right. Now, again, I think it's better to not have a million things on one graph. Just make a new XY axis, nice clean one. And let's do one that doesn't come out to an angle that you know. Remember, you're going to use inverse tan at the end then. 3 comma 1. Graph 3 comma 1, and then tell me what it would be in polar. We narrowly missed Friday the 13th there. Because today's the 13th. Comma 1, and you go over 3, and you go up 1, and you put a dot. Then you make your little triangle, and you go, this is 3, and this is 1, and that side must be square root of 9 squared, 3 squared and 1 squared, which is 9, and 1 makes 10, square root of 10. Raise your hand if you had square root of 10 in your answer. Excellent. So it's the square root of 10, comma, the angle. And I don't know that angle. I don't have it memorized. So I just go inverse tan. TOA is opposite over adjacent, 1/3. Raise your hand if you had that one right. Okay, awesome.
You can just leave it like that?
Yep. Now, the only way to get that angle would be to type it into a calculator, and then you'd be getting a decimal, which wouldn't really be accurate anyway because it's a decimal. Everybody thinks the decimals is accurate, but they're not because you can't, they have to eventually round them, and this isn't rounded. So this is the accurate, exact answer. Yes?
Can you use something other than tan?
It's not advisable. I get what you're saying. You could have, for example, said inverse sine of 1/10, but we are okay. So let's go to, how could we make this more complicated? Well, with the different ways to write an angle. Here's one. This spot right here, let's say I mean it to be 8 comma 3 pi over 4. What else could I have said that would get this point? Remember, these are points. That point, black point right there. What's another way I could have said it? In fact, give me 3 different ways I could have said that same point. I know a lot of you are thinking, well, I had one. Think back to coterminal. Yes?
8 comma negative 5 pi over 4.
Correct. That's one way. You've taken the easy way. Can you also step up and take a harder one? Hint, go past it all the way and come back to it.
8 comma
Hint, it's 8 pi over 4 to go around once.
8 comma 11 pi.
There it is. And give me one last way. It's funny if I meet somebody's gaze and they like, look away quick. It's like, don't call on me. Gilday, can you do it? That one was already up there, negative 5 pi over 4. So what's another way to do that? Go all the way around and past it and come back to it. Okay, would you agree that going all the way around once would be negative 8 pi over 4? And then you just kind of back to where you started. Maybe does that help?
So -13.
There it is, our 13 theme, negative 13 pi over 4. Any questions on that one? Okay, so there's a lot of different ways we could say that point. Here's one more way that you're not going to like. You remember how we always said that radiuses couldn't be negative? Well, we were keeping your life simple. Kind of like, how do babies get born? Storks. It's the stork. Storks bring them. Yup, because you weren't really able to handle it yet. Well, now you're able to handle it. Wait. I refer you to your health teacher. So you are going to now figure out where the heck negative 2 comma pi over 4 is. And it isn't going to be where you think it is, and you're not going to like it. So, do you remember when I first taught you how to do cotangent, and I said, you have my permission to say I refuse to do cotangent, Mr. Server. Instead, I prefer to do tangent. And then I'll flip it at the end. It's kind of like that. So when we say to go here, don't go there. Go here. Do you know where 2 comma pi over 4 would be? Okay, everybody go there. Put a dot where you think 2 comma pi over 4 would be. Regular, the blue one is normal, 2 comma pi over 4. Basically right about there. I might be off a little bit. I'm going to try it again. About there. Okay. Now, here's how you navigate to negative 2 comma pi over 4. First of all, the 2 is kind of, we call this an r. This is r comma theta. Theta is easy, that's an angle. But why are we calling this an r, a radius? Because do you get if you just had somebody standing in a room and you said, walk 2 feet? Like, okay, but that could be in any direction, right? You know what I mean? If you're starting at 0, 0, you could walk 2 feet in any direction. Do you get that that's why they call it a radius? Because if I just said go 2, and I had to say feet at least to give you a chance, you'd be like, well, I don't know which way you want me to go 2 feet, but if you went all the different directions in 2 feet, it would be like this. See what I mean? So it would be a circle with a radius of 2. Okay, so back to, how do you find this actual spot then, Mr. Server? You go back to where you started from, and then the other way. That's negative 2. And you put a dot. Now you might be like, but that's not pi over 4. That's why you're not going to like it. You wouldn't have said, if I asked you where this point was, you wouldn't have said negative 2 comma pi over 4 for sure. If I had asked you where is this point, you guys, you would have said 2 comma 5 pi over 4 would have been the most common answer. If I'd asked for a second answer, it probably would have been 2 comma negative, what do you think? 3 pi over 4. You guys have been all happy with that, but you would have never said this, would you? But you could have, because it's in the same spot. But then, I know, it hurts your head. So, it's the opposite direction than what you would think. You're just going to confuse me and you, but go ahead. Okay, wait. So, you asked me about 2 comma negative 3 pi over 4. If you're going to plot that, nope, that's where it is. This is here, which is here. That's all good. It's only the ones with the negative radiuses that are really confusing because the angles don't match up with what you would think.
I meant negative 2.
Okay, negative 2 comma negative 3 pi over 4. Let's investigate where that is. Negative 2 comma negative 3 pi over 4. Everybody make a separate graph. I had to have some point anyway. Let's use that one. Now, to graph this, I encourage you to say, I'm not going to graph that. I refuse. Peaceful resistance. I am going to instead graph 2 comma negative 3 pi over 4 because I know where that is. Do you guys get the 2 comma negative 3 pi over 4? Here's the negative 3 pi over 4 part, and here's the 2 part. It's that spot we were just talking about. So that tells you, okay, you should go through here. And that's the answer. If it hurts your head, you're normal. If you're totally understanding it, it's because I'm such a good teacher. Just kidding. Yes? Oh, great. Polar coordinates are handy for things like navigation, like in the ocean. And so this is something that you might find there. The negative is just about direction. So that's, in the past, we've never let direction be negative or distance be negative. We've let directions be negative, but we never let a distance be negative. That's why it's probably going to bother you the most, is because we always said distance had to be positive. But so I'm going to go with navigation, because get how north, south, east, and west are kind of like the same as the angles here. So, all right, let me get you through a little further here. Everybody, without any help from me, where's negative 4 comma pi? Did you say to yourself, self, I would rather do 4 comma pi? So I'm going to do that. And here's where pi is, and here's where 4 is, so I say that that's 4. If you're confused on like how far that could be, just pick an amount. Like, I want to make it inches. Well, that's pretty big. Maybe centimeters. If you're not sure how big a centimeter is, and I like to have this be 4 centimeters. A centimeter is like the width of your pinky fingernail. That's about a centimeter, and it's pretty standard person to person. I know they're not all the same, but they're all pretty close to a centimeter for an adult-sized human. All right, so is that the actual spot though? No, that was to help you find the actual spot. The actual spot is back here. Raise your hand if you had that one right. Awesome. So I like to think of this as those points are related to each other, but they're obviously like opposite of each other, kind of. And so it's kind of like, did you know that right now, somewhere in the United States or in the rest of the world, there's a person who looks almost exactly like you? It's really scary to think about, but there's somebody who's walking around looking almost exactly like you. If there was a picture of them, your friends would all mistake them for you. Okay? It's true. And I know we're all different, like we have different, like a snowflake, right? You've all got different fingerprints, and that's all cool. But somewhere there's somebody just like you. And so there's a website dedicated to this called Doppelganger. Have you ever heard of Doppelganger? It's a German word for like your evil twin kind of thing. And so even though they aren't necessarily evil, in fact, they probably aren't, this other you somewhere else could be thinking right now about their doppelganger, and it's actually you. There's this website. What it does is, if you submit your picture, they'll see if they can find somebody that looks almost exactly like you that submits their picture, and then they'll contact both of you, and they'll be like, "Hey, we found somebody that looks almost exactly like you." That's kind of a cool idea. This is polar. You'll be able to be successful today if you can answer this question. 4, 7 pi over 8 is where? And what would it be if you had to make its r negative? Another name for this point would be negative what comma what? This is really kind of a mind melt. Well, first off, you should have said it was about here. See that red dot there? Raise your hand if you had a red dot or a dot in that general area. Okay, good. What would it be? How many of you were thinking, I'm going to go over there and put a dot? Raise your hand if you were thinking that way. That was the right way to be thinking. What you were finding there is kind of the doppelganger, right? And it's also 4, but we're going to call it negative 4. And this spot right here would be 4 comma, if you just had to name it without the whole negative thing, it would just say it was 4 comma what? Not 7 pi over. Think in terms of 16 pi over 8 would have been the 15 pi over 8. So you use that to say this point then is actually negative 4 comma.
Oh, that point.
This point here
15 pi.
is negative 4 comma 15 pi over 8. So always find the doppelganger on the other side. Figure out which one's just normal, doesn't have a negative r. And name it. And then you can just zip it over to the other side by making it negative. So this one's here. This one's there. Okay, and one last skill is if I give you this rectangular coordinates, 2 comma, let me think, square root of 3. That's rectangular. Graph it and figure out what the polar would be. Young Hai, what shape do you end up making from the geometry world when you go to 2 comma pi over 3?
The triangle?
Yeah, somewhere like there. I'm not sure exactly where because I don't know how long square root of 3 is, right? Okay, I think I put it more like that. And then, did you actually label the sides? Okay, so where should I label them?
2 would be the hypotenuse.
All right. Actually, it's the x value.
Oh, yeah, my bad. Yeah.
Is it the opposite, adjacent, or hypotenuse?
It'd be the adjacent.
Okay. And then square root of 3 is here. And what's the other side got to be? Yuck. I designed this one poorly. Now, it's not impossible. It's not fun, though. This last side would be the square root of square root of 3 squared is 3. 2 squared is 4. Square root of 7. How many of you had square root of 7? That's awesome. Square root of 7, comma, and then I have to do inverse something or other. Say it if you know it. Inverse tan of what? Root 3 over 2. If you could handle that one, you are way ahead of the game. That's awesome. How many of you were able to handle that one? Awesome. Okay. Then you get the beginnings of polar. In the beginning. All right, so you've done polar. Now we got to grade your lab. So I'm going to stop the video right there. There is homework, and you should do some, and there's a Dropbox, and you should Dropbox what you do. You don't have to do them all. Do a couple. Do a few. All right, but Dropbox them before tomorrow at 8 a.m.